Okay, so today when we are moving into lesson 8 in our unit 7, we're going to be solving equations that involve negatives, okay? So that's our learning goal today, being able to solve equations and involving negatives. So we're going to kind of use a process here, and these are the steps I want you to follow to help you be successful with these, okay? So the first thing we're going to do is we're going to look at the problem, and any subtraction in the problem we're going to change to what? Add the opposite. So let's fill that in to remind ourselves that changing subtraction to adding the opposite helps us be more successful with what are we really doing. Okay? And then we're going to change the order around if we need to. And what property allows us again? What property of addition allows us to change the order we add in? Let's just see. Commutative. So COMM. U. TA. Commuta. TIVE. Commutative. The commutative property allows us to change the order around. And the reason we're going to change some order around is so we can put terms together that we call like terms so that we can combine them. So our next step is going to be if there are any like terms on one side of the equation, we're going to add them together because we'll have an addition problem from our first step. Everything will be addition. We'll use the commutative property to change up the order if we need to. We'll put together like terms, and now we will be ready to solve. And remember, when we solve, we have to keep the equation balanced. So all that other stuff we were doing, we don't have to worry about doing that on both sides. That's just getting the equation kind of like ready. Once we start solving, though, now we're doing something that we have to make sure that balance scale stays balanced. So whatever we do on one side, we have to make sure we do on the other side. So we are going to do the same thing to both sides of the equation to solve it. So those first three things, we're getting the equation ready. Then we're going to actually go to work solving it. And when we're solving, we have to do the same thing on both sides. Okay, let's get started here. We have this negative 5, subtract x, add 5, add 5x, and all that is supposed to be equal to 12. And the goal is to eventually solve this for x, the variable that's in it, the unknown. So what was our first step? Add the opposite. How many subtractions are going on the left side of the equation? How many subtractions are there? Caden? Just one. This is a negative 5. So it's going to stay a negative 5. This subtraction is going to become an addition, and if we're subtracting, we're going to slip up a 1 in there because isn't there an invisible 1 there? They don't write it. This is really a 1x being subtracted. So we're going to change it to what is the opposite of 1x? Class? Negative 1x. And now it's plus 5. We don't need to change that. It's already add. It's plus 5x. We don't need to change that. It's already add. And bring along our equals 12. Okay, so we've done the first step. There was some subtraction to change, so we changed it to add the opposite. The next step says rearrange if you need to so that we can move into that third step, which says combine like terms. We're going to always let the variable terms take first place in the expression. So we're going to move the 1x to the front. What other term would be like that one? What would be a like term? Yeah, the 5x. So we'll let the 5x come second. And then we'll let the constants, we have a negative 5 plus a negative 5 and plus a positive 5. So you see where we got all of those? Negative 1x was in the second place, it went to first. 5x was in the fourth place, it moved to second place. Negative 5 was in first place, now it's in third. And positive 5 was in third place, now it's in fourth. All 4 terms are still there, we just rearranged them. And then we bring along our equals 12. Let's put a box around the sets of like terms that we have. So these x's we would say are like terms. These constants are like terms. What can we do to combine that first set of like terms? What can we do? How do we combine negative 1x plus 5x? Anybody have any idea? By taking 1 away from 5, by subtracting a negative 1, by subtracting just 1. Okay, let's open up your algebra tile bags now. Sure. Since we're not really sure, but do you have the x tiles only right now? Get off the x tile. And could you model on your desk for me that negative 1x and that positive 5x? Could you model that on your desk? The x tile. So, don't get carried away, don't get on a whole bunch, just get on what you need basically, and model on your desk a negative 1x plus a positive 5x. What would that be on your table there, on your desk? It's kind of like, it's just an expression, we don't even need an equal sign right now, we're just looking at our box of like terms. So looking at Derek and Kaylee's and Manny's, oh, that's just a plus sign, and Wade's, and Pikea's, and I can't, oh, this is yours, Harley, and Harley's. It looks like, and Sam's, and, where's that there, Sam? No, that would not be a negative 1x and a positive 5x. And Tyler, so you should have 5 green x tiles, right? And 1 red x tile, right? That's what should be modeled on your table on your desk there. Okay, well now tell me, what could you do with that group of tiles you have there? Anything you think you could do? Danny? You got a 0 pair there? So in other words, one of your green x tiles can pair over that red one, and they can be taken off because they're a 0 pair. And what do you have left? You have 4x left, don't you? Yeah. So it appears that negative 1x plus 5x is what? 4x. 4x. So in other words, what we're doing is we're combining negative 1 with positive 5. When we have a negative 1 plus 5, we should end up with a positive 4. So we have a positive 4x. That's what our x tiles combine to be. Tell me what would happen with that other group of like terms, those constants. What would happen there? Wait. They turn into 0 because what's true about those two numbers? What relationship do they have? They're what? What relationship do negative 5 and 5 have? What's the word that we call them? Sylvia, they're opposites. So yes, they zero each other out, don't they? They zero each other out because they're opposites. So this is going to become plus 0. So if we put our algebra tiles on our desk, they would become, we'd have 5 of the negative unit tiles, we'd have 5 of the positive unit tiles. They would match up with each other and zero each other out, all of them, right? There wouldn't be any of them left. They'd all get to be gone. And so now we have equal to 12. Have we done anything yet to really solve this? Remember, solving is when you do the same thing to both sides of the equation. Have we done any solving yet? What do you think? Or have we just done what I just said up here, those first 3 steps? Getting the equation ready. Have we done any more than get the equation ready? No, we haven't, have we? We have not even started solving this, and that's important that you understand that we haven't even started solving it. All we've done is prepare it, get it ready. kind of another word that they use in math for it is simplify it. So now we're ready to solve it. What do you think we can do in this particular case? 4x plus 0. Do you think we could just cross out that 0? Why could we just cross out that 0? Sylvia? And when you add 0 to something, does it affect it? No, adding 0 to something does not affect it. So what you can do is, it's kind of like you're playing with the algebra tiles. You can say these guys are going to wipe out. They're going to be gone. They're not there anymore. So now we have 4x equals 12. Now we're going to do the same thing to both sides to solve this. What would we do? Any ideas? Katie? Sarah? Divide both sides by 4. The x's need to be divided into 4 groups because there's 4 of them. They're kind of like in charge. Each x wants to be by itself, so since there's 4 of them, we divide by 4, which means on the other side we need to divide all those unit tiles into 4 equal groups also. So what does our x equal? 3. There is what we call our, let's write this behind it after we circle. This is our solution. We have solved that equation. Questions, anyone? Okay, here's what I want you to do right now on your table in front of you. Before we do the check problem, we're going to kind of almost like check it with the algebra tiles and see if we get the same thing, okay? So, I want you, this is after we changed it to an addition problem totally, I want you to model that on your desk. Now, would you use your pencil as the equal?
This is LeGrand.
Yes,
Do you have Roman Ochoa?
I do.
Could you come to the office for a minute?
Sure.
Thank you.
So, would you use your pencil as like the equal sign? So on one side of the pencil, you need a -5, a modeled, you need a -1x modeled, you need a +5, you need a +5x. On the other side of your pencil, you need 12 modeled. Make that equation on your desk. Just put your pencil vertical. Put your pencil vertical. It's going to be your equal sign. It's going to divide the equation. So I want you to make this equation on your table for me. -5, that would be 5 negative unit tiles. If you don't have enough unit tiles, you keep your hand up, we'll see if we can scrounge some up for you. Harley. So no extra things in this equation, no like making equal signs or plus signs with the tiles. I just want the tiles to model the equation. And the pencil is going to be the equal sign. everything I have highlighted at the top should be on the left side of your pencil. Everything I have highlighted at the top, where you see some red, should be on the left side of your pencil. And then what should be on the right side? Should be on the right side of your pencil.
Okay, wait a moment, I don't know what's going on here. So let's just make it 5.
What should be on the right side of the pencil?
5.
Positive,
Okay.
12, what size tiles?
Minus X.
Unit tiles, the little squares, right?
No, on this
Okay.
side, where's your minus X?
So I want us to be able to see how what we actually did with just the pencil and the paper,
Plus 5.
how we were getting the equation ready to solve, getting it to the point like we did last week, where we divided them into equal groups. Right now, it'd be kind of hard to divide into equal groups, would it not?
Okay.
What do you think? If I said to you, would you divide them into equal groups right now, would you be like,
Those over here.
what?
No. You could.
I think I would be.
Equals 12.
So, is everybody ready almost? Okay, well, you need some unit tiles here.
Just put this up here. Okay, so you have 5. So,
Okay, how are we doing over here? You got it? You got it? Because I want you all to be able to participate here to see that what we just did to get the equation ready, you're going to be able to do the same thing with the algebra tiles. Okay, so the first step, of course, was changing it from subtraction to add the opposite. So we kind of skipped that step because we needed to, we went from, we'd already done that step, and because that's what we need to do anyway to use algebra tiles. The next thing that we did is we rearranged so that like terms were beside each other. In other words, we grouped things that looked alike beside each other. We changed the order up. So on the left side of your model, on your table, would you rearrange, would you just rearrange, putting the X tiles first and the unit tiles behind? Do not mess with the other side of the equation. We did nothing on the other side of the equation with that 12. We only rearranged the left side. We put the X tiles beside each other. We put the unit tiles beside each other. So it's almost like now we could put a box around them, so kind of like, almost like, separate them from each other, the unit tiles and the X tiles, and say, here's a group, here's another group, here's my pencil for the equal group sign, and then I have 12 unit tiles. Okay, well, we already practiced this one thing with this. What did we do? We took, what was the next thing that we did after we rearranged and put them together in groups? What was the next thing we did? See if there were any zero pairs. So we looked at our X terms. Do we have any zero pairs in our X terms? Yeah? Okay, so take a zero pair away from your X terms. Take a zero pair away from your X terms. Move them out of the way. Get them out of there. Zero out some X terms. That can be X tiles. One has to match with the other. This is a zero pair. Okay? That comes out here. Okay? Then we looked at the units and we said, what can I do there? Well, what did we do? What happened? What did we say it was? 0. And is that what's going to happen? Can you pair all of them up and get rid of all of them? Yeah? Okay. So now what does your model look like? What's left? What are those? Four X, 4 positive X tiles, and what's on the other side? So I've asked you to take away the 0 pairs, and the only thing that should be in front of you now are 4 X tiles that are positive on the left side, and 12 unit tiles on the right side that are positive. Now what do we do? Well, now what did we do last week with something like this? Divide them into equal groups. Would you do that now, please? Divide them into equal groups. So, when I look at your table, I should be able to see an X tile. I should be able to tell what each X tile is equal to. So your pencil still stays there as the equal sign, and on one side, I can't tell here what X is equal to from your model here. According to your model, it almost looks like maybe X is equal to 7, maybe it's equal to 5, maybe it's equal to nothing, I don't know. Like it's equal roots? Well, then how are you gonna make them equal roots? You divide this into 4 groups, you're gonna divide that into 4 equal groups. Make it happen. Okay, so, yes, Harley? No, you may not. So, the reason that we are doing them both without algebra tiles and with algebra tiles is you should be able to put together, when we are doing it abstractly with just pencil and paper, what are we doing, and you see it happening with the algebra tiles. Okay, I want you to slide those algebra tiles out of your way for a bit, and we're going to do a check problem. Let's do a check problem. Slide those algebra tiles in front of your table now. Grab your pencil, get your equal sign pencil. Grab your notes page, and let's do a check problem. Okay, when we do a check problem, we are not doing solving. We do not do the same thing to both sides. Remember, checking is substituting and evaluating. Okay, we substitute and we evaluate. So we are going to, first of all, though, we are going to change it to add the opposite again. And let's stick in that 1 that was there. So the only step that we are going to do like we did above, we're always going to change subtraction to add the opposite. So everybody do that first. Now we will substitute in what we found X to be and see if it'll make this equation true. So -5, there's nothing to sub in there. Plus -1, it's supposed to be multiplied by the X value that we found to be 3. So we can show it in parentheses like that. That means multiplication. So we're substituting 3 in for X. Plus 5, there's nothing to substitute there. Just bring it down. Plus 5X, we'll substitute in place of the X a 3 because that's what we solved X to be equal to. So 5 with a 3 in parentheses means multiply. So this is called substitute for X. Okay, would you write that off to the side? We substituted for X. Because these check problems are going to be just as important as your solving problems. Okay? What comes first in order of operations, multiplying or adding? Harley? Yes, you may. You're really going way behind you, so that's fine. What comes first in order of operations? Adding or multiplying? Okay, multiplying. So we're going to go focus in right now on these guys first, okay? So let's put a box around them. We have a couple of multiplications, and since they're away from each other, we're going to do both of them at the same time. Is that okay? So we have a -5 plus. What's -1 times 3? Negative times a positive is a negative, and 1 times 3 is 3. So that substitution, that multiplication becomes -3. This plus 5 doesn't have anything to be done to it. 5 times 3, 15. We bring down the equals and the 12. We are not solving, we are substituting and evaluating. So we just did the multiplication. Now we're going to start adding from left to right. Okay? So let's take care of these guys first. -5 plus -3. What is that, class? -8 plus 5 plus 15. -8 plus 5 next. Caden, -3. -3 plus 15, Ikea, 12. 12 equals 12, true or false? True. So we say it checks. Yep, it checks. We have a good solution. Questions? Okay, let's go to the back. What's first? What's first? Add the opposite. Looks like we have a subtraction between the x and the 2, so we'll change it to add what? -2. The opposite of 2 is -2. This one was already addition, so we don't need to change it. Okay. What's the next step that we're looking for to see if this needs to be done? What's the next step we're going to look to see if it needs to be done? Sylvia? Okay, see if we need to, anything needs to trade places. Does anything need to trade places in this one? No, this one's already in good order, isn't it? So we get to skip that step. Okay, the next step is what? Combine like terms, which yes, we'll add when we're doing that. So combine like terms. What are the like terms? X, does the x have any other x's to be combined with? No. So how can we add x to anything if there are no other x's there to add it to? Any other terms that maybe could be like terms? They're on the same side. Harley? -2 and -4. They're on the same side, so they're like terms. When they're on the same side, we call them like terms. So we have x plus what? What's -2 plus -4? -6 equals -5. Okay, quickly model that with here. Started the way it was. Started as x plus -2 plus -4 equals -5. Quickly. You guys should be really quick at this now. X plus -2 plus -4 equals -5.
Oh, you want to move it?
From where we changed it from add to add the opposite, yeah. X plus -2 plus -4, remember your pencil is the equal sign for temporarily, equals -5. Everything's negative except the x tile, right? So now, what can be combined? What can be combined because they're on the same side? The negative unit tiles, right? Push them together then. How many are there? No, that's not on the same side. They gotta be on the same side to get pushed together. Push them together only if they're on the same side. Let me see what you got going here, girl. Okay. Let's suppose for a moment. So now what do you have on your table in front of you? Tell me what the equation reads. X plus -6 equals -5. Okay, now what are we gonna do? We need that x tile all by itself. What are we gonna do to get that x tile by itself, Roman? There's gonna be something we can do. Help. What can we do to get that x tile by itself? And it has to be something. Now we're ready to solve. So whatever we do, we have to do it to both sides, by the way. You can't just say, oh, take away those 6 red tiles, because if you want to take away the 6 red tiles, do you have 6 red tiles on the other side to take away? No, you only have 5, so you can't do that. So, Tyler, what do you think we can do? Oh, it's on hand, so I'm giving you a chance to.
You can do very good. 5, take away 5, take away 5 from this one.
So you could take 5 away from each side, right? Okay, you could do that, that'd be one thing, but then we kind of would almost have like another step to do. So let's see if we can do it without having to make it into another step yet. Sylvia? Add 6 unit tiles to both sides. Okay, so she says add 6 unit tiles, so that would be the tan side. Would you add 6 unit tiles to each side? And why are we doing that, Sylvia, by the way?
Because you can do that.
So we can get some 0 pairs, we can get those guys out of there. That will get that X alone, won't it? If we add 6 to the left side, as long as we add it to the right side, we can do that. So what happens after you add those 6? Well, do we have 6 0 pairs on the left side of the equation? Yep, get them out of there then. Let that X be all by itself, it wants to be alone. Do you have any 0 pairs on the right side now? How many? 5. We'll get those 5 0 pairs off the right side then. So we get them out of there. So now X is by itself on the left, and what's left on the right side? 1, a positive unit tile or a negative unit tile? A positive unit tile. Yeah, so let's do what we just did. We added 6, so we're starting to solve now. We added 6 to get those guys to 0 out, so X could be by itself. That was the goal. That's why we added 6. We wanted these guys out of there. So now if we do that on one side, we have to do it on the other. These guys zeroed out, right? And X was all by itself now. And you told me that 5 of these 6 zeroed out with that. So what was left? 1. Is negative 5 plus 6 1? Yeah, it is, isn't it? So X equals 1 is our solution. And that's what your algebra tiles are showing also, aren't they? At least a lot of tables I saw, that's what I saw. Okay, so now let's check that. Even though we've solved it with paper and pencil, we've solved it with algebra tiles. Let's check to see if when we substitute it in, but first we have to change this to add the opposite again. Let's see if when we substitute it in, do we get a true statement. So what's going to go in for X? 1. And that's the only place we have to do a substitution. If you line them up vertically like I do, it's going to make your notes a lot easier to follow when you have to do it on your own without me guiding you. So it's all addition on that left side, isn't it? So let's just start right away at the left. What's 1 plus negative 2? 1 plus negative 2. King? Negative 1. And now we'll add these guys together. What's negative 1 plus negative 4? Negative 5. We end up with negative 5 equals negative 5. True or false? True. Checks. Okay, we're going to do the next one without algebra tiles. How you're going to do it in your homework, okay? So, do we have any? Okay, I already see you putting algebra tiles away. So go ahead, just get them put in there, I guess. Oh, but we're gonna finish these notes, so you gotta be efficient. Look on the floor. You're not taking them to the back of the room right now, though. And that is just gonna go where your brain wants to be, I guess. we're done, so, everybody ready? What's the first thing we gotta do? Add the opposite. Well, -10, that's not a subtraction. Oh, here's a subtraction. Subtract -5, we're gonna change it to add what?
The opposite.
What is the opposite of -5?
Positive.
+5. What's the next move getting the equation ready?
Like terms together.
Well,
Like terms together.
don't we want to rearrange first?
Yeah.
Okay, who gets to be first?
Yeah.
3x. Who gets to be next?
-10.
Doesn't really matter. -10 can be or 5 can be. There were no other x's, were there? Okay, we've rearranged. Do we have any like terms? Yes, we do. What are they? -10 and 5 are like terms. So we have 3x plus what?
Positive or
-5. -10 plus 5 is a -5. All of that to get our equation ready to solve. Okay, now what? What would we do if we did have the algebra tiles in front of us? The 3x says, get those guys out of there. Get rid of those -5. How are you going to get rid of that -5? Sierra? No, we're not going to divide. What are we going to do, Harley?
Or 5 positives.
We need 5 positives. So we'll add 5. If we add 5 over there, we have to add 5 on the other side to keep it balanced. So now this is that set of 0 pairs, isn't it? That gets that 3x by itself. So 3x is now all alone over there. What do we have on the right side now? 15. 10 plus 5 is 15. And now what? Oh, we're not done yet. We don't know what x is equal to yet. We have 3 x tiles on one side and 15 unit 1 tiles on the other. What are we going to do? We need the x tiles. Oh, no, Hannah. Don't even think about it. What are we going to do next? Harley.
-3 each.
No, what are we going to do, Danny? Divide by 3. There's 3 x tiles. We need to divide them into 3 equal groups. So if we divide the first side by, the one side by 3, we got to divide the other side by 3. So how much would be in each equal group? 5. So x equals 5. Okay, I'm going to leave it to you to have that checked out and finished for me for class tomorrow, okay? Along with the homework that I'm going to have done. You are going to need to do homework done, and you're going to want some of the notes from another day. Also, along with today's notes, I do want to just point out one thing after everybody has these